Hi everyone and welcome to 5 Minutes Cybersecurity. Today we are going to talk about one of the simplest methods in cryptography, the Caesar cipher. It's named after Julius Caesar who, according to tradition, used it to securely communicate with his generals during military campaigns. I don't know if Julius Caesar really used it in practice. Anyway, let's see how it works. Essentially, the Caesar cipher is a substitution cipher in which each letter in the original message is shifted by a certain number of positions in the alphabet. For example, with a shift of 3, the letter A becomes D, B becomes E, and so on. If we encrypt the word hello, still using a shift of 3, the word H becomes K, E becomes H, L becomes O, and O becomes R. So we obtain something like CUR, which is our encrypted message. Now let's encrypt the sentence meet at 10 in front of the charge. For simplicity, let's consider the number 10 written in letters instead of digits. With this phrase and a shift of 6 positions, the message becomes this one. We have now the encrypted message, and in order to decrypt it, we need to know the number of shift positions used in the encryption phase. We can think of this number as the key for this cipher. Without the key, it's difficult but not impossible to decrypt the message, even if there are only 25 possible shift positions in the English alphabet. This concept of key is fundamental in cryptography. You may be wondering, why do I say there are only 25 possible shifts if the letters of the English alphabet are 26? That's because a shift of 26 position would basically return to the original letter, meaning that the message would not be encrypted at all. Therefore, when using the Caesar cipher, we only consider 25 possible shifts to create a meaningful encryption. This algorithm is extremely simple, and this simplicity also makes it vulnerable. A determined attacker could easily decrypt a message encrypted using this method by simply trying all possible combinations, all possible shifts. You might think that this could take too much time, especially if the message is really long. However, someone trying to decrypt the message can focus on decoding just few words. If, using this method, they are able to find meaningful words, then they have found the key of the cipher. This algorithm has a number of vulnerabilities. As we mentioned, there are only 25 possible shifts, meaning that with a brute force attack, it's quite easy to calculate all the possible combinations and find the correct key. Additionally, even in the encrypted message, the letter's frequency does not change. For example, in the English alphabet, the most frequent letter is E. The second most frequent letter is T, and so on. And this kind of information can also be leveraged to decrypt a message encrypted using the Caesar cipher. A simple improvement could be made by choosing a longer and more complex key. For example, by applying 2 different shifts instead of just one. We could shift the first letter by 5 positions, the second letter by 2, then again the third letter by 5, then by 2, and so on. In this way, in order to decrypt the encrypted message, you need to know 2 numbers instead of just 1. And with this, we have slightly improved the algorithm. We could further enhance it by continuing to add even more shifts to the first, second, third letter, and so on. In this way, our key will become longer and more complex. Even with this improvement, the algorithm is not secure. and it should not be used. Essentially, only the words are encrypted, while the spaces remain unencrypted. Therefore, if we frequently find a 3-word letter in the encrypted message, we might suspect that this is the word "the", and we can use this information to find parts of the key. Despite all these considerations, the Caesar cipher is a good starting point for understanding more complex concepts. That's it for today. Thank you for watching. I hope you have found the content useful. Don't forget to like the video, subscribe to the channel, and see you next time. Bye!